Hi friends, welcome back to Edupedia World. Today we will begin a new unit that will be calorimetry, and today's discussion will be focused on the topics of heat, temperature. We'll understand what heat means, what does temperature mean, how do they interact, and then we'll see the units for both of them. And we'll conclude today's lecture with a simple discussion about how much heat is stored in a body, or how much heat is required to raise the temperature of a body by a particular amount. Okay, so let us get started with calorimetry. We will start with concept of heat and temperature. Heat and temperature. We know that anything, any body, any object made up of a lot of molecules or atoms. Now these molecules are in a state of continuous random motion. So these random motions is equivalent to kinetic energy, since motion results in a kinetic energy. So the kinetic energy due to the random motion of the molecules or atoms is the heat energy. So basically, what is heat? It is the kinetic energy due to the random motion of molecules of substance. Molecules or atoms of the substance. So heat basically represents the net total amount of kinetic energy due to the motion. Now what does temperature represent? Temperature represents the average kinetic energy of the molecules of a body. Temperature is the average kinetic energy of the molecules. So heat is the sum total of the kinetic energy. Temperature is the average kinetic energy. Now what will happen if we supply some amount of external heat to the body? What that will do is that will increase the random motion of the molecules of the substance. As a result, the total heat content of the body will increase. But the point to be noted is, since the heat energy, the total heat content is increasing, the average heat content is also increasing. As a result, the temperature of the body will be increasing. So you supply heat energy, you raise the temperature. You take away heat from the substance, the temperature goes down. Okay, so this is the holistic picture about heat and temperature. Now suppose that we have two bodies which are placed together. So let's say this is a body and this is another body. Now if this is T1 and this is T2, where T1 and T2 are the temperature of the body, not the heat content, the temperature. And if T2, let's say T2 is greater than T1, then the heat will flow from the body which has higher temperature to the lower temperature. So heat flow, the direction of heat flow is determined by the temperature. It always flows from higher temperature to lower temperature. It might be that the body T1, since it has a larger amount of substance, it might have a net total higher heat content, but that will not define the direction of flow. The temperature Gradient will define the direction of flow. Direction of heat flow, direction of heat flow is from higher temperature to lower temperature always. So now we have some idea about heat and temperature. Let us see what are the units of heat and temperature. So the unit of temperature, you might have heard about it a lot of times because it is a very common thing that we measure. What is the temperature outside today? What is the temperature of Delhi today? So we know that the unit of temperature, let me write it down. Unit of temperature, the most common unit that we use in India is degree Celsius. Okay, so how many degrees Celsius is the temperature today? But the SI unit of temperature is called Kelvin, represented by a K, Kelvin. There are other units like degree Fahrenheit, which is normally used in United States. And there are certain other units which are not commonly used. So these are the most commonly known units of temperature. Now what is the unit of heat? The SI unit of heat is called joule, represented by capital J. We have already met this unit when we were discussing about work. So work and heat, both being energy forms, has same unit, joule. There is an alternative. This is the SI unit. Let me write it. SI. This is also the SI unit. An alternative unit of heat is called calories. Calorie. This is not a SI unit, but this is also a very commonly used form of energy. How do we define a calorie? Let me define what a calorie is. Calorie is the amount of heat used to raise heat required to raise temperature of 1 gram, note it's 1 gram of water from 14.5 degrees Celsius to 15.5 degrees Celsius. So a calorie is basically the amount of heat that raises the temperature of 1 gram of water by 1 degree Celsius. But that 1 degree Celsius is specific. It's from 14.5 to 15.5 degrees Celsius. Why so? Why has it to be 14.5 to 15.5? Because the amount of heat required to raise 1 degree Celsius varies from where to where the temperature is raised. Like if you raise the temperature from 5.5 to 6.5, then the amount of heat required is not exactly 1 calorie. It is exactly 1 calorie only from 14.5 to 15.5 degrees Celsius. Okay, now we know what a calorie is. We know that the joule is the SI unit of heat. So what is the relation between calorie and joule? Let me write it down. 1 calorie is 4.186 joule, or approximately equal to 4.2 joule. Sometimes we use this. We can use this. If the question does not state, we can use either of them, but this is the more accurate conversion equivalence. So what we see is that a calorie is larger than a joule by how much factor? By a factor of 4.186. So now we know the equivalence between joule and calorie. There are other units of heat which are kilojoule and kilocalorie, which will be basically 1000 times joule. So kilojoule will be 1000 times joule, kilocalorie will be 1000 calories. So with this idea, now we have over holistic picture about heat and temperature. What does this mean? How does heat flow? What are the units of heat and temperature? Now let us see the factors which affect the heat content of a body. Okay, so how much heat is basically contained in a body? The way to go about it is think about if you have a body which is 1 kilogram and another identical body but the mass of it is 2 kilogram. So you can automatically think that obviously the 2 kilogram body, which is identical in every other sense to the 1 kilogram body, will have more amount of heat inside it because it has more mass, right? So one of the important factors which define the amount of heat content, I will represent the heat content of a body by Q, is that it is proportional to the mass. Okay. Now the second thing is that suppose you want to raise the temperature of a body by 1 degree Celsius. You have one body, you have two identical bodies, let's say. Both are of, let's say, 1 kilogram mass made of the same material. Now, if you want to raise the temperature of one of them by 1 degree Celsius, but the other by 2 degrees Celsius, then obviously the one in which we have to raise it by 2 degrees Celsius will require twice the heat than the case in which we require to raise the temperature by 1 degree Celsius. So the amount of heat we need to give to the body to raise the temperature will be directly proportional to how much raise of temperature do we want, right? So Q will also be proportional, directly proportional to delta T. How much temperature increase are we going for? And finally, Q will be a property of the material of the body. Some material will require less heat to raise the temperature of 1 kilogram by 1 degree Celsius. Some will require more heat. So how do we define that property? That is a material property. We say that Q is proportional to C, where C is a material property. Material property. So effectively what we are saying is that the heat required to raise the temperature of a body by delta T, which has a mass m, will be given by mc delta T. That m is mass, c is the property of the body, and delta T is the rise in temperature. Now C is called the specific heat capacity of the body. Today's lecture I will not go into details about what specific heat capacity is. That will be covered in the next lecture, but for the sake of completion of the topic I will mention it here. C is the specific heat capacity of the body, and this is a material property. Okay, so with this I will close today's lecture. The next lecture I will be covering heat capacity and specific heat capacity in details, and in that lecture, after the detailed coverage of these two concepts, we will see some examples and some numericals. So till our next class, have a great day. Goodbye.